Good morning, good afternoon, good evening, wherever you are in the world. My name is Steve Robinson. I'm one of the business development guys at Galarath, and today, again, following on from some of the other series of movies that you may or may not have seen, we've been asked by a couple of our customers to talk about how do you calibrate SEER for hardware. What's the point of calibrating SEER for hardware? For those of you that are potentially unfamiliar with SEER for hardware, that is a top-down parametric estimation tool for mechanical and electrical components and assemblies. And the whole point of calibrating it is to add confidence to your estimate, to be able to utilize corporate data, to be able to share that corporate data and that corporate knowledge with the user community who may not be familiar with it. There are some health warnings that go with that. Obviously, the data that is used to calibrate the model needs to have a high degree of confidence associated to it. It also needs to be relevant to the project and the estimate that you are attempting to calibrate. Calibration in SEER for hardware is a multi-step process. We're going to cover, I'm not covering them, of course. My colleague Keith Garland, who is our technical manager here in the UK, is going to do all of that for us. We're going to cover most of the stages. The ones that we're going to skip over are things like creation of knowledge bases within SEER for hardware. The reason that we're going to skip over those is because we're going to do a session specifically on knowledge base creation and how and why to do that as well. So there's a lot to cover today, probably about 20-25 minutes of your time. If you have any questions, my details are on the screen, Keith's details are on the screen. Fire the questions over to us. We will be more than happy to help, more than happy to answer anything that you may wish to ask. So given that this might be longer than some of the other sessions, I think it's probably best to hand over to Keith now to go through everything, and I'll catch up with you all at the end. Keith, over to you, sir.
Thank you, Steve. Hello, everybody. So today, like Steve said, we're going to look at calibration within SEER for hardware. So to start off with, I'm just going to start an estimate, and I'm going to do what I would do as the first level of calibration. So I will always select knowledge bases. Now, knowledge bases are going to put you in a position of knowledge. They're going to be a good fit. It's better than no knowledge. So rather than have to set all the parameters from scratch, I would use Galarath's industry norms that we're using here to allow you to preset the model on your behalf to give you, in that very first level of calibration, an estimate out of the box from SEER, from Galarath. Go on to next. So I'm starting a project. I'll just enter some quantities. So we're going to make 10. I'll just make 10 in 1 year. Set the project parameters so I can work in imperial or metric. As you know, within SEER, I'll work in metric today. I'll keep in British pounds. 2020, everything's fine. Click on OK. Click on Finish, and the model will go to its 4-pane configuration that you're probably familiar with. If you're not, it's user inputs at the top, model outputs at the bottom. The top left is the building blocks, the work elements where we will generate our cost. Top right are the inputs that control that cost. These are the things that the knowledge bases will set on your behalf, and outputs at the bottom from SEER. So my first work element I'm going to insert is going to be a mechanical structural. It's for the nose cone itself. And if you're unsure what application to choose, we have a wide range here available to you. Don't forget, we can use the help here and we can search through the help on for keywords, and I'm looking and I found a nose cone here under aerodynamic surface, so that will be the one that I will start from. So this is my position of knowledge, and off we go. And if you'd seen my estimate yesterday, I can also use the your company 2020 EC economic rates if you wanted to. So that's just highlighting what we've done on labour rates in H previously. So we have our first estimate. It hasn't got any cost, it hasn't got any design cost, development cost, anything until we enter a weight. So we'll enter our weight, and we know this to be a 6.35 kilogram nose cone. We have no uncertainty. We know exactly what it is. We've built it, we've weighed it, and here we go. I'll put in the volume, so it fits in 3/4 of a meter, so it's only a small nose cone. And we have a cost. So this is basically the very first level of calibration by basically utilizing SEER, not starting from scratch, not setting every parameter, and having to think about all of these things which we have worked over many years to set up on your behalf to save you time. The general rule in SEER is if you don't know anything better, trust the knowledge bases and only change them if you do know better. So that's level one. Level two is you know better. You probably know that it's going to be a composite nose cone, for example, and this is only going to be between 5, 10, and 20%. We know that this is going to now be 80%. This is going to be 60. This is going to be 90. So we have some uncertainty still, but we have a range of materials, and obviously based upon that, we now have a calibrated or a second level of calibration by better information. We've refined our estimate. We know better. We actually know also that our labour rates are okay because we've put them in on our 2020 rate, so we don't need to change them. Anything else we want to look at? We know that we've changed it to composite, so maybe the complexity of form, which rates the overall complexity of the assembly, may be less. Maybe there's a part count reduction simply because now we have, instead of lots of multiple sheet metal parts, we have plies are different. Our construction process, we can put that up a little bit because we're going to hand lay it. So we've increased that. So now we're reflective of our estimate, and I'll come here, I'll right click, quick estimate options, and we'll turn on some of the things that we're interested in looking at. So we want to know what the average production unit cost is. We want to know what the material cost is. We want to know what the total development cost is. That development cost, that's fine. We want to know the production cost and so on. So that's okay. So we'll just refine that. And as you can see now, we've got a new cost. It's gone up a little bit because it's now made a composite. It's a slower construction process, but we're happy with the number, but not quite. So maybe we need to now consider calibrating this. So we can go into calibration mode and we can refine our estimate. So I just want to turn on one more quick estimate options, is the schedule, because we'll calibrate the schedule as well. So we cannot make these in under 15 months from scratch. So we need to refine that estimate. We know the raw material actually cost us 1,500, for example. So we need to calibrate the material cost. So what we have to do is, I just need to move this menu. We go to advanced and we go into calibration. Now you'll see a new tab has appeared called Calibration Factors. And over here, we have the estimate, the actual, and the difference, and the calibration factor. So a new report has appeared called Calibration. A new tab has appeared called Calibration Factors. So what do we know? We know that the schedule is going to be 15 months. So in here, we can type 15. This is a known cost. We're comfortable with it. We know exactly the reasons why we take longer than Mr. Gallagher thinks it should be. So we're happy to do that. So we have an actual, we have an estimate, we have a difference, but we also have a number here, which is the key. So always remember, it's the calibration factor number that you need to enter. So we come down through the list until we find something called class adjustments. Now, class adjustments, like class knowledge bases, have the highest precedent in the model. So nothing you could do other than that will overwrite it. So it's important that we enter in class adjustments so that our alterations remain constant. So in here, this one, simply double click, enter 16%, click on OK. And you'll see our number now isn't exactly 15, just nuances of the model, but we are now calibrated to what we believe it to be. I come back up to the top. We also know our development hours were, I don't know, because we took longer, we probably took longer here. So I'm going to say our development hours are 1500. Now, if you look at this, you can actually calibrate individually each work element, or if you haven't got the detail but you have a total number of hours, you can apply the same calibration factor to each and every one of these calibrations here. So what we're saying here, 1500 hours is what it took. We haven't got a breakdown for the detail, so we'll just apply a factor to each one of these as we do it. So I'll click on OK. And there's only a 2% difference. Is it worth calibrating? Maybe, maybe not. But for today, it's worth calibrating. So I'm going to come down to the class adjustments. And because everything is common here, what you can do is simply double click at the top line, put in our 2%, and everything goes to 2 in that category. And that list here, design, prototype, engineering, test, corresponds exactly with the list that is here. So I'll just show you something else while we can do this. So I'm going to just remove that value. Click on OK. I'm going to come down and I'm going to remove this value. So we've gone back to where we were 2. So maybe we have a little bit of detail on what the actual design effort was. Let me just look at the detailed estimate. Design, it's not in hours, it's in cost. Oh dear, let me just guess it. I'll come back and we'll go to our calibration report, come back to the top over here. And in this one, we're going to say we only have no more detail other than design. So in design, I'll say it was 500 hours, maybe a mile out. Let me just say, oh, there we go. It's not too bad. The estimate was 401. The actual was 500. So my calibration is 24%. So I need to come down again to my class adjustments. Let me minimize that one. So design is the only one I know. So I put, is it minus? Oh no, 24%. And okay, so now we've calibrated just design. So whereas before we altered everything, we had some specifics, so we could put in exactly what we knew for design, and we could go through each one of these in turn and calibrate them individually, which is what we can do. And it's exactly the same in production. So if we look at our production hours, 2000. So I'm going to come here, come to the top, and again, in production, if I put in 1800, so we were more efficient this time, click on OK. I got to reduce my class adjustments by 10, and I have to adjust every one of these because I haven't got fabrication hours, I don't have production support hours, I don't have tooling maintenance. But if you did, again, same principle as before, put in the lower number here, just check the one that you're trying to calibrate against, and then you would have that capability to do so. Today, we're going to do all at once. Click on OK. And we have to put in a -10 in our production labor. -10. And hey presto, we have calculated and calibrated more production hours. Our material cost was more, it was 1,500. So again, back to the top, material cost was 1,500. And OK. And in the material, my mistake, 15,000. Click on that one, that looks better. And again, we're going to put in 10% to calibrate that value. So that's how we would calibrate. Now, the point of this now is we have these numbers, we've calibrated to it. So best practice would be to create a knowledge base, making these changes, adding in the calibration factors as we've done so. And in our next webinar, we will show you how to build a knowledge base and how to enter calibration values in that knowledge base. That's not for today, but it is the final stage of calibration using this method. So that's all we have to do is enter the values at the top, read off of the chart here the calibration values, enter them into the class adjustments, either for development, production, materials, schedule, whatever we know better information around. And our calibration report, I'll show you it in full, does come up with different adjustment factors. It tells you a lot more information of what you've done. And again, you can print this off and make references to it, etc. So that's one way to calibrate. So what I'd like to do now is show you how to do what I will call a best fit calibration across a range of nose cones. So the easiest thing for me to do now is delete this one because I'll save it so I can come back to this one to do later in the day. Save file, desktop. And save it. So now I'm just going to delete this one. And we're going to do some, and we'll come out of calibration mode. So now I'm going to do a range of nose cones. So bear with me while I just create a few. Insert a work element, mechanical, structural. And I'm going to copy that one, insert paste another one, insert paste another one, insert paste another one. So this is going to change the name. No guesses for what it's going to be. So this could be a Airbus nose cone, this could be a Boeing nose cone, this could be a Lockheed nose cone. And I'll just change that one to large. And this is going to be so this is going to be a lot more complex. Okay, so we'll just quickly put some weights in. So the small one is going to be between 6, 7, and 8 kilograms. This one is going to be between 12, 14, and 15. This one is going to be 20, 25, 40. And the final one was around that weight, so it's going to be 16, 18, and 20. So we have costs now for each one of these. Things here will alter. So we could have a composite nose cone, we could have an aluminium cut nose cone, we could have a combination of the both. But for simplicity, all I wanted was different values to calibrate against. So ranging from 13,000, 9,400, why is that one more? No, wrong, 24,500, 45, 31. So obviously they're expensive nose cones. Labor rates are probably high. So what we have to do is, again, we will go into calibration mode. And we need to calibrate each one individual. So let's have a look at the schedule. So the small one will take us 20 months. I put the value in, yeah, it's all right. Schedule, 20. The medium takes 21. The large takes 22. This one is complex. This one takes 24. So we have some values across there, and each one has individual calibration values. We'll come back to this one. We'll look at the development hours. Development hours, we can do this one in 1500. We have a calibration value of -18. And okay, this one is 3,200. So this one is going to be 3,000. And in here it's -9. So if you notice this time, I'm putting in the calibration values. And right, here we go. So first thing I got to do is go back. You don't put the calibration values in. That's my mistake. You put in the actuals and development schedule. That's right. Nose cone. Right, so we're only putting in the numbers. So we're putting in that one. We're putting in that one. We don't put the calibration numbers in yet. Sorry, that was my mistake. Going ahead of myself. So that was 22. That one's going to be 6,000. This one is going to be 4,200. And the schedule's done. Just check there's nothing in there. Okay, so don't put the calibration values in, just put your actuals in. That was my going ahead of myself. There we go. So we've calibrated our, I'll only do the two. We've calibrated our schedule and we've calibrated our development. And obviously you can do production and you can calibrate individual ones like we saw earlier. So the key to this now is this one's -18 at the top there. That one's -9. That's +3. That's +1. So at this level here, we now have, let's go right across, and I'll maximize that. So the calibration report now is giving us a lot more information, but what it's telling us is what the calibration factors need to be. Okay, so the estimate, the actual difference. So this is what we will put in, -3 and +18 into these two categories, because this is now the best fit across nose cones. All right, so whether it be a small one, a medium one, or a large one, or a medium one, what you would do now is we would come to this one, come back up to the top, sorry. What's happened? Come to this, do it here. So in each one of these, I'm looking at the wrong place, that's why it's not there. I'm going to put -3 and +18 into each one of these. So -3. Can I do that? Yes. So let's put that one in. And in the schedule, I need to find a pair +18. We'll copy that, paste, paste, paste. So now we can come out of calibration mode, remove that. So these are all now calibrated, and these are now not exactly correct, calibrated as they would be calibrated individually, but they are the best fit across the range of one. So if you wanted to build a generic nose cone that's going to be the best fit across your entire portfolio of components, whether it be wings, whether it be spars, whether it be ribs, whether it be electronic boxes, this is the way you would do it. You would calibrate across each one individually, and then you end up with the best fit for what we're trying to achieve. So that is basically calibration. Like I say, level 1, always use knowledge bases. Level 2, refine the knowledge bases with the better information that you know, whether it be material composition, whether it be capabilities of the people, experience, production facilities, and you then get a better answer, more appropriate because of the knowledge that you know. Level 3 is going in and calibrating each one individually. So I have a best fit for small nose cones, and I have a knowledge base for them, and I have another knowledge base for medium, or finally, you can do a best fit across all of them, so you have one nose cone knowledge base that has been calibrated to do all of them, but some's going to be a little bit high, some will be a little bit low, but actually it's going to be the best fit. So I hope that's been of benefit to you. Please feel free to ask us any questions, come back to us, willingly help you do further studies if you have any questions. But I'll pass you back to Steve, and thank you very much.
Thank you, Keith. As we sort of said at the beginning of all of this, calibration should not be entered into lightly, particularly the latter stages, that final step of going through the calibration factors and making sure that information is available. It is vitally important that the data that is used is used appropriately and has a high degree of confidence associated to it. The calibration process is for let's call them a power user. It is not something that we would encourage a regular day-to-day user to get involved with. We have some very specific and very detailed training to help support that. What we've hopefully done today is provided you with an indication of the art of the possible, what can be done. There is, as Keith mentioned, there is steps that you can follow to make best use of that calibrated data so that it can be shared across the user base. That is through the creation of knowledge bases. We are going to cover that, Keith and I, in another session that we will be sharing with you in the near future. As we said at the beginning, and as Keith has just said, if there are any questions, our details are on the screen. Please do not be shy. Send us over any email questions that you may have. We will be more than happy to help and support those. And once again, thank you for your time today. Thank you, Keith, for yours. And we will see you at the next one. Thanks a lot.
Thank you, Steve. Goodbye, everybody.